All right, let's look at parallel lines. So parallel lines are coplanar lines, meaning two lines are in the same plane that do not intersect. That happens is when these two lines are in the same plane and have the same slope. They have the same rate of change. They have the same steepness, right? If one was steeper than the other, then eventually they would hit either above or below. So they have to have the same slope. And what we want to do is we want to find like the equation of a parallel line that goes through a specific point. So let's just do some examples. So let's say I have this point, 2 comma 5, and then I have this equation, y equals 3x minus 4. Okay, and so I want the equation of the line that goes through this point and is parallel to that point. Okay, well, this one has a slope of 3, so that means I need a slope of 3 for this line. Okay, so I'm going to find the equation of the line now using y equals mx plus b. I'm going to use the y value of 5, the slope of 3, x2, then I'm going to find the b. So this is 5 equals 6 plus b, and if I solve for b, I get negative 1. And so then I get the equation y equals 3x minus 1. These two lines are parallel because they have the same slope, and that this line goes through this point. And so graphically what I was doing, this looks something maybe like that on a graph. And then the new one that I found looks like this. It's parallel and looks like that on a graph. They both have the same slope. This has a y-intercept of negative 4 and this has a y-intercept of negative 1. Okay, so I found the equation of the parallel line that goes through a given point and is parallel to some other line. Okay, what about, I want to go through the point negative 4, negative 3, and I want to be parallel to, let's say 3x minus 5y equals to 10 or something. Okay, so the first thing you want to do is if you want to be parallel to this line, let's find this line's slope. So I'm going to leave the negative 5y alone. I'm going to move the 3x over by subtracting it, and I'm going to divide everything by negative 5. Negative 3 divided by 5 is 3/5, and then positive 10 divided by negative 5 is negative 2. This really is fairly irrelevant in the conversation. This tells me that I want the slope of 3/5. Okay, so if I want to be parallel to this guy, I have to have the same slope as that guy. And so I want to go through this point and have this slope. Okay, so let's use y equals mx plus b. I'm going to plug in the y value that I want to go through. I'm going to use the 3/5 slope that I want. I want to go through a negative 4x value, and I want to find the y-intercept. And then I can write the equation. Because remember, to write an equation, I need the slope and the y-intercept. So this is going to be negative 3. This is going to be negative 12/5 plus b. And then I'm going to add that over. Negative 3 plus 12/5 equals b. Let's make that negative 15/5. Remember, I multiplied top and bottom by 5 because I need a common denominator to add these. Negative 15/5 plus 12/5 is negative 3/5. And that's equal to b. And again, once you have the slope and you have the b value, then you write the equation. Y equals 3/5 x minus 3/5. And I know these numbers look similar, but that's just total coincidence. I just randomly made this point in that graph. Okay, so this line is parallel to this line, same slope, and it has a y-intercept so that it goes through that particular point. And again, that's really what you're doing. They could ask you, instead of finding the equation, they could say, hey, is this 3y minus 12x equal to 16, is that parallel to 4x equals y plus 5? Are those two lines parallel? Well, to decide whether they're parallel or not, you have to decide whether they have the same slope or not. And they actually could be the exact same line if they have the same slope and the same y-intercept, so we don't really want that. So we want to show for them to be parallel, we want to show that they have the same slope and a different y-intercept. Okay, so all we have to do is really solve for y. Let's do this one. So if I move the 5 over, this one really is y equals 4x minus 5. That's easy, right? And then this one, I'm going to move the x over. Let's write it actually down here. So I'm going to add that 12x over to the other side. And then I'm going to divide by 3. And you can see they have the same slope and different y-intercepts. So they would look, something like that with a slope of 4 and a y-intercept, and this one's got us, 16 thirds is like 5 1/3, so it's like way up here. So they would look something like that if you graph them, okay? These two are parallel lines. They, of course, they're on the same plane because we're graphing them on an xy plane, right? All these axes are in an xy plane, and they have the same slope and different y-intercepts. So with parallel lines, those are probably the three biggest examples. Given a point and something already done for y, just find the equation. I could give you something funky in like standard form and go through this point. Again, you need to find the slope of the line you want to use, and then the point, and then with a point and a slope, use y equals mx plus b to find the equation. And over here, deciding things are parallel is just deciding whether or not they have the same slope. Okay, hopefully this helps you get started and answer some questions about finding equations of parallel lines and deciding whether things are in fact parallel.